Hi, and thanks for joining me for our Calc 1 video on limits of a function, and hopefully this will be the last one of the series, just introducing you on evaluating limits of functions algebraically using a table and also taking a look at their graphs. Alright, so let's take a look at this last problem here. So we are asked in this problem to graph and determine the following limits of this function, and there's my highlighted function. And so we can go ahead and take a look at the graph of this, and we can certainly use our graphing technology to help us out, whether that's through Desmos or some other online graphing calculator or our actual graphing calculator. So I'll go to my y equals. I will carefully type in the function, making sure that in my denominator is the 1 minus 2, and the 2 is raised to the 1 over x. And then I'm going to hit zoom 6 just so I can see it in a standard window, which for us looks like maybe negative 10 to 10 for x, negative 10 to 10 for y, and we'll take a look at what that looks like. Alright, so what I can see is that this does appear to be a discontinuous graph. There does appear to be a jump right here at x equals 0, and that should make sense to you because if I put 0 in for x or do that substitution, I have 1 over 0, which is undefined. So that does sort of make sense here, so I will graph it. Now, if I wanted to get a better idea of what it's doing as it's approaching 0 from the left and as it's approaching 0 from the right, maybe I want to do my window myself. So maybe I'll just look negative 5 to 5 for x, and I believe I'll do the same thing just for starters for the y value to see if I can get a little bit more detail in this graph than I currently have right now. What did I do? Oh, and excuse me, I typed in negative 5 instead of positive 5. So we want our window to go from negative 5 to positive 5, and then negative 5 to positive 5 for y. So let's see if that gives us a better look here. So I can see my graph coming down and approaching 0, and it does look like it sort of almost curls there a little bit at the end. And same thing here, it looks like it starts after 0 and goes on this way. Now if I tried to calculate a value at x equals 0, it should leave blank because I should have a hole, which means that both of those points are holes. This one appears to be 0, 1. This one appears to be 0, 0. So I will take this graph and I will draw it over here to the best of my ability. In this case, I'm actually just going to copy and paste, but I'll have the graph. Okay, and what I'm going to also do to this graph here is add these holes. So there's a hole at 0, 1 and a hole at 0, 0. All right, so let's take a look at the first thing it asks me for. Limit as x approaches 0 from the right, 1 minus 2 to the 1 over x. So that would be, there's a couple different ways I can go about this. So I can go about this by looking at my function and saying if x is approaching 0 from the right, that means number theory-wise, or thinking about the parity of number, not its actual value, but whether or not it's positive or negative, separated by whether it's large or small. So if x is approaching 0 from the right, x is going to be a very small number, but positive. So I can write x is approaching small, positive. And then let's substitute in that idea into our function here. Well, the first place that you would, and really the only place you're substituting in an x is in that denominator. So I'll say 1 over x then. Well, this is the reciprocal function. If you reciprocate something small, you get something very, very large. And you can test that. X is small, so it's something like 0.00000001. If you reciprocate that, you get a very large number. Still positive. All right, then, now I have that 1 over x part calculated. So now I can say, well, what would 2 to this 1 over x be? Well, it's going to be 2 to a very large positive number, which is going to approach positive infinity. If you think of 2 to the 1,000,000th power, you're approaching positive infinity. All right, so now I have this whole part right there calculated. So that leaves me with, in my denominator, 1 minus that 2 to the 1 over x. Well, 2 to the 1 over x, we just said is approaching infinity. 1 minus infinity is going to approach negative infinity. All right, so that's my denominator. So really I have 1 over negative infinity, or negative large. Okay? And 1 over negative large is really, really small. How small? Approaching 0. Now, what about the negative part, you might ask? Well, we will approach 0 from below. So what I actually showed you in this problem, and we're going to do it again, don't worry, is a little bit of number theory sort of idea here. If you start with, what does x just start with? What kind of number are you trying to be? Small or large, positive or negative, so separate those two items. So I'm saying x is some small number and positive because I'm approaching 0 from the right, and on the right are the positive values. And then substitute that into your function, piece by piece, right? So the first piece that you would be evaluating is the 1 over x, which is that reciprocal. So that's why I got the second component there. And then you'll notice I also started using or introducing the idea of infinity. You could have kept with the large or small notation here and just said that was positive large. And then I would have said 1 minus some positive large number would be a negative large number. And you can write negative or positive in words, or certainly with the symbol. So you could do it that way as well. So what I see is, as I'm approaching 0 from the right, so I'm coming in this way, right, and I'm approaching 0 from the right, indeed, it should approach 0, and the negative part told me from below the axis. So those y values are very, very small, but negative. So let's take a look at what happens if x approaches 0 from the left. These values are small, but negative. All right, so then I'm going to put it first of all into that 1 over x, just like we did before. Well, now I'm reciprocating small, so it will be large, but when you reciprocate negative, you still are negative. All right. So I've taken care of this part. So you can look at the denominator all as one part if you want to, but I'm going to still keep it kind of separate here and just do it one piece by one piece. So now I would be evaluating 2 to the 1 over x as an exponent. Well, 2 to the large negative number. If we think about what that looks like maybe numerically, I mean, give yourself an example here. Maybe this is something like 2 to the negative 1 million. And again, 1 million is not actually close to infinity, but you know, it's big enough for us to probably get the idea here. Well, a negative exponent, remember, reciprocates. So this becomes 1 over 2 to the 1 million, which is actually going to approach 0. And it'll approach 0 positive, right? So if you, from the positive side, right? Not 0 from below, but 0 from the positive side. The negative exponent reciprocates, doesn't actually look like a negative number when you're done. So that's the 2 to the 1 over x piece. So okay, I've got that whole piece now. So I'm going to put it in the rest. 1 over, well, let's just do this piece by piece here, just like I said, sorry. So let's not do the fraction yet. Let's do 1 minus 2 to the 1 over x. Well, this is going to, since 2 to the x went to 0, 1 minus 0 is going to approach 1. Again, x is approaching a small negative number like 0. X is not equaling, so we're saying this is an approximate value. Well, this will be approximately 1. Okay, and then that's my denominator. So 1 over 1 will approach 1. And that's why we can see that we have a hole at 0, 1 from the left. So let's verify that that's what it looked like graphically. So do we have a hole at 0, 1 when we approached from the left? Yes, we were coming in this way, remember, and we said that that hole looked like it was at 0, 1, and now we know it is. Okay, so last question here. If I ask you what is the limit as x approaches 0 and I do not give you a side, you're going to be able to tell that that limit does not exist. All right, so why does this limit not exist? Let's write this out. Limit of my function, I did call it f of x earlier, so I can call that out now. As x approaches 0 from the left does not equal the limit of my function as x approaches 0 from the right. Again, this y is very important, and you're going to need to be able to write that down in most of your quizzes or tests and identify in limit notation, or you could, if you're writing it out, write it in words, but you'll have to recognize both. You also saw that graphically, right? Because not only do you have a discontinuity in your graph here, but you can easily see that those limits are not the same. The last idea that I will leave you with is if you went to look at a table of values here, what you would see is 0, right, does not exist, right? There's that error that we would get. And because 1 over 0 is undefined, and that's the first place we have to put x in. And so if I put something in like negative small and positive small, I'm just using 1/1000th as my small, I will see that from the left, this is actually going to approach 1, and from the right, this is actually going to approach 0. Again, these might not be exact values, but that's what my table of values is going to show me. So I hope that gives you a good summary on your beginnings of limits and helps you identify when a limit does exist and does not. And I hope you can connect at the end of this section, I hope you can connect the graph, right, with the table of values with some algebra, and on this example, some number theory. So I hope that helps you along your way. Thanks for watching.